In certain circumstances, such as disease or anatomical issues, breathing can be difficult. For some, when we sleep, our tongue blocks our airway, preventing air from entering our lungs and causing us to snore. For others, such as asthmatics, our airways overreact, producing too much secretions that block surface space needed to exchange carbon dioxide for oxygen. In extreme situations, the drive to breathe is completely lost, and in those times, a tube would be placed in order to breathe for the person until they can do so on their own again, like a break for your lungs. But this comes with a whole list of other complications we want to avoid. When someone is having trouble breathing but still has the drive to breathe, there is a device that can assist. BiPAP, biphasic or bi-level positive airway pressure, is a device that gives two pressures, hence the bi, which means two. These two pressures, inspiratory and expiratory, help facilitate deeper breaths. Let's look closer at the two pressures, starting with the expiratory pressure, also known as positive end expiratory pressure. This is when you exhale. Normally, there is air left in your lungs, kept there by a small pressure so that our lungs don't completely collapse. Every time a part of your lungs completely closes, it's very difficult to reopen. So it would be no good to have that happen every time we breathe out. If we add more pressure when we exhale, we can keep these parts of our lungs further open to allow more in, like opening and closing a door, but never closing the door fully to allow more people in. The second pressure is inspiratory pressure. This is the pressure that really gives BiPAP its name. When we inhale, we have to pull air in, and to pull all by yourself when there's obstacles in the way can be mighty difficult, so we add a push to help. Giving this little help can take some pressure off of the person breathing, allowing them to take deeper breaths without the added effort. This deeper breath increases a person's tidal volume, which is a fancy way to say all the air that enters and exits your lung in a single breath. This increase in tidal volume directly impacts how much CO2 is able to exit your lungs and oxygen enter. We want to keep these nicely balanced in order to keep homeostasis. So how does this work? Well, the machine constantly gives an exhalation pressure until it detects a reduction in pressure, which is a signal that inhalation has begun, and so gives the inhalation pressure until pressure increases, which is a signal that exhalation has begun. This little dance allows us to take deeper breaths and get rid of all that CO2. See, CO2, well, the amount that we have tells our brains when to breathe. So if we have too much, then our brain tells us to breathe more. And therefore, if we take bigger breaths, then we can slow our breathing.